Greetings, Math 122. We're going to do some practice problems from section 2.4. A lot of this deals with imaginary numbers. Just a couple basics to get started. If you can always remember that the square root of -1 equals I. Okay, don't let it get any more complex than that. This is called an imaginary number. And it's interesting to think just for a minute, how did we get to imaginary numbers? So if you think of people very primitively doing math, counting things, didn't really even understand the concept of zero at first, but then they introduced the concept of zero. And then they added negative numbers, the idea that maybe they had borrowed money from somebody and they still owed it back. Eventually, math became more complex and more sophisticated, and we needed to get to the point of understanding what imaginary numbers are. So think about those concepts. Again, just keep track. In fact, I'm going to stick it up in the corner of this board. The idea that this is what I is equal to is -1. So don't let it throw you. Goodness, you can't quite see that. So let me adjust that up just a little bit. I had adjusted it down. And there we go. I think you can see that now. So it doesn't get lost over there. So let's just walk through a few problems. So what I'm doing is I'm grabbing some problems out of the back of the book or out at the end of this section. So if you are looking in your textbook, you have an online textbook, go to section 2.4 and go to the end of section problems. Number 11 is 2 plus the square root of -25. And the instructions say, write this complex number in standard form. So what is standard form? A plus BI. So you have a constant portion and you have a complex portion. So the 2 just stays 2 plus, and I'm going to rewrite this -25 as -1 times 25. So we can clearly see this -1 piece, which turns into I. So 2 plus, okay, the square root of -1 is I. Square root of 25 is 5. So the answer is 2 plus 5I. Let's do another one that maybe isn't quite as, let's see, number 15 is the square root of -40. So as I like to do, I like to factor things out. So if we factored 40, we have 2, so 2 times 20, well 20 is 2 times 2 times 5. And I always check my work to make sure I got it right. So 5 times 2 is 10, times 2 is 20, times 2 is 40, times -1 is my -40. When I want to take the square root of something that isn't really obvious, I factor it out and I look for groups of 2's. Well, here is 2 times 2. I know what the square root of -1 is, right? That's going to be I. I have a 2 times a 2. Take the square root of that. That gives me 2. What's left inside is 10. So I can do it times the square root of 10. Okay, so that's my answer for that. Let's do another one. Let's try number 20. Let's see what we think about number 20. So number 20 says -2i squared plus 4i. So again, I need to factor that out. So how would I factor it out first? What do I see in common? Well, I see a 2 and I see an I. Let's see what other pieces I find. Let me back up for a minute because I wrote up here what square root of I, or square root of -1 is equal to I. What happens if I do I squared? All right. I squared is literally -1, square root of -1 times the square root of -1. let's write it like this. So I squared is equal to simply -1. Because if I'm taking the square root of something that's squared, then those two functions cancel each other out. So I squared is equal to -1. Let's see what I cubed is. What is I cubed? Well, it's I squared times I. So I have -1 times the square root of -1. It's the negative, whoops, I wanted to simplify it. It's -I, okay? One of the videos I shared on Canvas does a really good job of spending more time on this. I'm trying to breeze through this, so I apologize. So I the fourth is I squared times I squared. -1 times -1 is +1, okay? So I know I blew through that. Check that other video out to see more of that. So if I'm going to simplify this, I have -2. What is I squared? Well, that's -1. 4. And then we're going to leave that I there. That I stays just fine because remember we want it in standard form, which has a constant component and can have an imaginary component. It doesn't have to, but it can. So I have -2 times -1. That's a +2 plus 4i. So this original equation can simplify to 2 plus 4i. Okay, so that's the practice we need to get under our belt first. But let's move on. Let's see. Let me jump down to oh, here we go. Let's do some, whoops, I was trying to leave that. This is number 55. And we're just going to do a little addition and subtraction here. So 2 over 1 plus I minus 3 over 1 plus I. Oh, that's a minus sign. Let me write that properly. So I have denominators that are not the same. So of course, anytime I'm going to add fractions, I have to get the denominators the same. What I'm going to do is my denominator is going to be 1 plus I times 1 minus I. So I'm actually going to give myself a little more space so I can write it. Right? Oops, I really want to make that a plus sign. Minus I. So if I multiply the top and bottom times 1 minus I in the first case and 1 plus I in the second term. So now I can get common denominators, so I can do my, add my fractions. So I have 2 times 1 is 2, 2 times minus I is minus 2I, minus, put a parentheses, don't forget that it's this whole chunk we're subtracting. 3 times I is 3, 3 times 1 is 3, 3 times I is 3I. And then what is my denominator? It is 1 plus I times 1 minus I. Now, so a beautiful thing will happen here. This is also called the conjugate. So hopefully you've noticed that term already. When the signs are different, but the terms are the same, those are conjugates of each other. So let's see what happens. So I have 2 minus 3 is a -1. Negative 2I minus 3I is minus 5I. When I do my foiling on the bottom, 1 times 1 is 1. FO minus I plus I minus I squared, right? So we remember that I squared is -1, so I'll be able to take care of that. So I have -1 minus 5I, 1I, negative I plus I is 0, so I get rid of the i's. 1 minus I squared is -1. So let's go ahead and substitute that in. 1 minus a minus 1. Whew, Oh, you thought we were going to divide by 0. Nope, we're okay. So 1 minus minus 1 is going to be 2. Negative 1 minus 5i over 2. And you can leave it like that, or we can write it, we can separate that out. So I have 2 distinct terms. Sometimes it's a little easier for us to see if we write it distinctly. Negative 1 over 2, so negative 1/2 minus 5i over 2. Okay. Typically, this is considered more appropriate just because it puts it in this standard form so that you can see what you're doing. All right. I'll let you look at that one for just a minute, and we'll find another one to look at. Let's do another one like that. Let's do 58. That one's a little bit different. So 58 says 1 plus I over I minus 3 over 4 minus I. Again, let me leave a little space so that we can 3 over 4 minus I. Again, I have to have a common denominator in order to add or subtract fractions. So my common denominator is just going to simply be these 2 denominators multiplied together. So this first one, I need to multiply top and bottom by 4 minus I. The second one, I'm going to multiply by I over I. So that looks a whole lot like foiling on top there, doesn't it? And I always double check that I write down the problems right, because I have been known to make a mistake. So 1 times 4 is 4. 1 times negative I is negative I. The inner term is plus 4i. This last term is a negative, or is positive I times negative I. I squared is negative 1. So it's going to be a positive 1, all right? Let me walk through that one more time. I times negative I gives me a negative I squared. Well, negative I squared is negative 1, so it's the negative of negative 1, so therefore it's a positive 1, okay? So this is the part that's going to get you is the sign. So just keep track of that. Again, I encourage you when you get ready to take your exam, over chapter, it'll be over the last part of chapter 4 and over chapter 2. Make yourself a little help sheet. I hate to call it a cheat sheet, but I'm okay with a little help sheet that kind of writes down some of these foundational items. So I times 4 minus I, so 4I minus, again, I've got that I squared, so a negative I squared is going to end up being a plus 1 minus 3 times I is 3I. Same denominator, 4I minus a minus, so plus 1. So now I can add my fraction because I have a common denominator. So 4, here, let me make sure that's off to the side. So 4 minus I plus 4i plus 1. So 4 plus 1 is 5. Let me collect all my terms that have I. So I have a minus I plus 4i, that's 3i, minus 3i. Ooh, that dropped out. Hot diggity dog. So that's simply 5. And then my denominator is 4i plus 1. And the cool thing is we can just stop right there or do a conjugate. So we haven't done that yet. The conjugate, we would multiply the top and bottom because just like we're not supposed to leave square roots in denominators, we shouldn't leave negative powers in denominators. We also shouldn't leave imaginary numbers in denominators. So we multiplied by the conjugate, which in this case would be 4i minus 1. If I can multiply top and bottom by the same thing, because of course that's like multiplying by 1. So 5 times 4i is 20i. 5 times negative 1 is a negative 5. When I multiply conjugates, it's going to be the first terms and the last terms. The middle term should drop out. So 4 times 4 is 16. I times I is I squared, which is negative 1. So I have a negative 16. Positive 1 times negative 1 is going to be negative 1. So I end up with a negative 17. And again, I would rewrite in my two separate parts. So negative 20 over 17i plus 5 over 17. And I know those seem like a little bit goofy numbers, but that's the correct answer. All right, let you look at that one for a second. See how we're doing on time. Okay, we'll do maybe one more. Let's do one of these where we use the quadratic equation, and we're going to end up something that has an I in it. Okay, so what's my quadratic equation? Negative b plus or minus the square root of, oops, I did it wrong, didn't I? B squared minus 4ac, the whole thing over to a. Where do I get my ABC? I have ax squared plus bx plus c. What's the purpose of this? This is to find the zeros, okay? So we were just talking about finding zeros. What happens if I end up with something that has an imaginary root, which absolutely happens all the time. So let me grab, let's try number 67. So I have x squared minus 2x plus 2 equals 0. And the whole purpose is, when I can't factor this, my AC unit or method doesn't work, or guess and check, I can't find anything that's going to work. Maybe even I put it in my calculator and I can't find the zeros, it returns an error, says it doesn't exist. But there's imaginary roots that do exist, and I do have to comprehend those. So I strongly encourage you to write out your ABC. It may seem like a waste of pencil, but it actually will help you. My coefficient of x squared is 1. My coefficient of x is negative 2. And then my c is a 2. So that when I go to plug it into my quadratic equation, I'm all set. So the negative of negative 2 plus or minus the square root of b squared, so negative 2 squared, minus 4 times 1 times 2 all over 2 times 1. So I have the negative of negative 2, that's a negative, it's a positive 2, plus or minus. So negative 2 squared is going to be 4 minus 4 times 1 times 2 is 8. So 4 minus 8 is a negative 4. 2 times 1 is 2. Right away I can see I could simplify some things. Let's take care of this numerator first. So 2 plus or minus the square root of negative 4, remember, is the same as doing negative 1. Square root of negative 1, which is I. Square root of 4 is 2 all over 2. So 2 divided by 2 is going to be 1. Plus or minus 2i divided by 2 is going to be I. So I have 1 plus or minus I. And that is actually the answer. Those are two different roots that we have where this thing would cross the x-axis. All right, let's do one more of those. Oops, let's leave that one out. I could have left that too. All right, let's do one. Let's see. Well, let's try 68. Let's just try that one. X squared plus 6x plus 10 equals 0. So my A, B, C, A is 1, B is 6, C is 10. So it's b squared, so 6. No, it's the negative b plus or minus the square root of b squared, which is 6 squared, minus 4 times a times c, all over 2a. So I have negative 6 plus or minus the square root of 36 minus 4 times 1 times 10 is 40, all over 2. Not a big surprise that we have a negative sign here when we're talking about imaginary numbers. I'm actually going to end up with negative 4 again. So negative 6 plus or minus 2i all over 2. So negative 6 over 2 is going to be, let's write it, I'm going to write it in 2 parts for you. Let's do this in 2 steps so that there's no chance. So we have a negative 6 over 2, which is a negative 3, plus or minus 2i over 2, which is simply I. So there's my answer. All right, I'm going to stop stop there for now. If you have questions, please send them to me and I can do little videos. Thanks, guys.